Hey everyone, welcome to Marvel Medicine. My name's Suhaib Chaudhry, and this lecture is on respiratory physiology. I noticed that many students have a tough time understanding respiratory physiology, especially with the negative pressures and transpulmonary pressures and things like that. And I don't blame you, it's a little bit confusing. I'm going to break it down for you in a way that will help you apply it to more complex concepts. And that's the whole point of us doing this lecture here, is that you understand the physiology concept, learn it, and then be able to apply it to pathophysiology. And I'll show you exactly what I mean. Everybody knows that there are lungs, and if you go to an anatomy lab sometime or watch a lung surgery on YouTube, just look at what it looks like. Look at the lung. What is the lung made of? Well, there's a respiratory tract, blood vessels, interstitium, lymphatics, etc., and so on, right? I want you to think of the lungs like big spongy balloons. When you blow air in them, what do they want to do? Contract back. Why? Because of elasticity. If you're wondering what elasticity is, go to our elasticity lecture to understand that concept. This is an important thing to remember, that the lungs always want to contract back to their resting state, their baseline. Now, second is the chest wall. What's the chest wall made out of? Muscle, tendons, bones, tissue. The way I want you to think of the chest wall is a skeleton with little pulleys, which are muscles and tendons, and the way it's shaped is like a cage. The way the skeleton is shaped with its tendons and muscles makes it so that it's like a tent, upright. And when you push it, it wants to push back, kind of the opposite of the lung. The point is that the chest wall will always want to expand to its regular cage or tent-like structure. Now, for this next part, you're going to need some water to help you really visualize and understand. So imagine your hands in a tub of water or a pool. Bring your hands close together and have your palms touching each other. Now, quickly bring your hands out in the opposite directions. What did you notice? That the gushing of water rushing into that space between your hands, right? Well, the physics aren't exactly the same, but that's kind of the way the lungs and the chest wall work. The lungs want to collapse, and the chest wall wants to expand. These two forces go in opposite directions, in and out. So what happens in the middle? A negative pressure, the way you felt with your hands in the water, in between your hands. So what's negative pressure? It's a bit hard to understand this, so I'll explain it in a different way. First, you have to know what positive pressure is. So let's say I have a balloon that's filled up, and I blow some positive pressure towards it. The balloon moves away, right? Now, let's say I create negative pressure, which is like a vacuum sort of effect, going the opposite way. So if I have opposing chest wall and lungs in different directions, the pressure in this space between them will be negative. This space is called the intrapleural space. So what does the negative pressure do in this space? It acts like a vacuum and pulls the lungs out. And what's inside the lungs? The alveoli. Well, what do they want to do when the lungs stretch out? They also expand. Now, this next concept involves the diaphragm. So we got the chest wall, we got the lungs, and now the diaphragm, which is a big muscle on the bottom of your chest wall cavity between your thorax and your abdomen. With inspiration, what happens is that the diaphragm contracts and pushes down. Well, what does that do to the intrapleural volume? It increases, right? Since there's more space. This is the important part. What happens to the pressure inside the thorax? It decreases. Remember the relationship between volume and pressure. As volume goes up, pressure goes down. So with inspiration, the intrapleural pressure becomes more negative. Well, what do the lungs want to do when the pressure is more negative? They want to expand, right? Like we said. So then what happens to the alveoli? They also expand. Once the alveoli expand, That creates a negative pressure inside the alveoli. Same exact principle. This negative pressure inside the alveoli is what causes air to move from outside of your mouth to inside your mouth into your lungs. Once the air moves in, it goes into the alveoli where the oxygen goes from the alveoli to the blood and carbon dioxide to the alveoli.